We're in part 5 now of the central nervous system. We're looking at the brain. And I want to bring to your attention, while we're looking at these fibers, which are the association fibers in red, the commissural fibers in green, and the projection fibers, which are in blue here, of the receptive or sensory, or the expressive here, motor type of activity. They're sort of cruising through these areas. Do you see that we're bypassing the ventricles here? Here's the lateral ventricle, the third ventricle. We have here some portions here in red that are referred to as the basal nuclei. The basal nuclei are the caudate over here, and the putamen and the globus pallidus over here. We're not including in the basal nuclei the thalamus, which is the next section down in the brain, which is the diencephalon. This is still part of the telencephalon, and it's part of consciousness. It's part of conscious movement. Okay, so if you're going to draw smooth, straight lines, if you're going to dance with grace, and not, how shall I say, stumble, or how shall I say, have vibrato in your writing patterns, that is to say, starting and stopping motion, and also the smoothness, the intensity of motion without jerkiness. People who have Parkinson's disease lack actual good function in their basal nuclei. And so we can sort of define the activity of basal nuclei as the deficits that are present in Parkinson's disease. Also, we can further illustrate it in terms of the hyperactivity or hyperstimulation. So there's the Parkinson's disease, which means that not enough dopamine, and so we have diminished function in the basal nuclei here. What happens when we have too much function, so to speak, overstimulation, then we get something that's referred to as schizophrenia. And so it's possible for there to be too much L-DOPA, shall we say. You have to be careful with dosage when you're trying to dose your Parkinson's disease patients to replace their dopamine. What if you give them too much? Then they end up in a schizophrenic state. Okay, notice that the internal capsule goes in between. This is referred to as the internal capsule, and it's basically where the projection fibers squeeze through between the caudate nucleus and the putamen globulus pallidus portions. So we have this tiny little area here where projection fibers can make their way through. That'll be an important little detail, too, in subsequent sections of the brain as we come down through. Let's take a look at this picture over here. Here we have, again, the putamen as well as the caudate nucleus. And so these are parts of the over here is the tail of the caudate. These are parts of the basal nuclei, not to be confused with the thalamus. And so these are elaborate, aren't they? Okay, they're quite extensive when we take a look at it. And we're going to be using all different parts of the brain. In order to do smooth activities, starting and stopping activities, it means that we're going to be having to be very, how shall I say, conscious of what's going on. So here we're looking at the text here, and it says that the precise role of the basal nuclei has been elusive, partly because of their position centrally located in the brain. We can't access them very easily, so it's hard for us to know over time what's been going on. There is a strong relationship with the cerebellum. Okay, so in terms of activities governed by the cerebellum, we also have refinement of intention. If I want to draw or to write or to dance, and I want to do it in a way that's smooth and graceful, then that's something that will be under the auspices of the basal nuclei. Okay, in addition to the motor functions, it says here, the basal nuclei play a role in cognition and emotion. You might have noticed that when famous people with Parkinson's disease, that would be Attorney General Janet Reno, back in the times when she was trying to figure out what to do with the, how would I say, there was something going on in Texas. There were the Dravidian group of people. She was speaking in public settings, and when she had strong emotion as a response to questions from the media, you could see her arms moving and gesticulating. And so this was an example of her Parkinson's disease. Muhammad Ali, the famous fighter, also was injured in terms of the amount of blows he took to the head, probably resulting in his Parkinson's disease. Again, his motor skills were greatly diminished. Cognition is playing a role there, and so you have sort of, how shall I say, value judgments that come into play here. So they say here that particularly important is the starting and stopping of motion. So that's where grace comes in. The monitoring also of intensity of movement. So you might accidentally move with too great force or too little force, and not have also in that way graceful movement. So gracefulness and smooth action in a lot of sports, oftentimes like cross country or cyclocross sports especially, where you have to go through lots of changes and adjust to lots of environments. There is a saying that we used to use, because I used to compete in those areas, is that smooth is fast. When you can make adjustments smoothly and gracefully, despite the difficulties, you can be faster as a result of the smoothness. Okay, so we'll pick up then the next stage here. Here we have a lot more nomenclature on page 440, and I'd like you to be aware of it. The cingulate gyrus here is very important as part of the limbic system, which is the system that guides emotional function and richness. We have these areas over here that we need to be learning about. Here is the mid-sagittal section through the cerebellum, which displays this portion here of the cerebellum that we refer to as the tree of life, or the arbor vitae, which is a translation into Latin of the tree of life. Notice that the cerebellum and the pons are at the same level, with the fourth ventricle intervening between the two. Okay, so here we have the thalamus at this position. The thalamus is an interesting unit, and we're sort of dipping into the diencephalon now. The diencephalon would include the thalamus, the hypothalamus, and the pituitary gland, along with actually the optic chiasma. Even though it's just a cranial nerve, actually, it is playing a role here with the hypothalamus in terms of transmitting light signals to the hypothalamus. And then finally, over here we have the pineal gland, which is also a part of this diencephalon set of structures. So here's the pineal gland, here is the thalamus, here's the hypothalamus, here's the pituitary. Pituitary is sometimes referred to as the hypophysis. Okay, so there are extensive features. It turns out the third ventricle is partly formed. The walls of the third ventricle are partly formed by the thalamus as well as the hypothalamus. Notice that the thalamus has this intermediate mass here. Over here, the interthalamic adhesion, it's called, or the intermediate mass. So the thalamus is actually two-lobed. okay, and it's connected in the middle by sort of its own little corpus callosum that connects left and right of the thalamus. The thalamus is actually got lots of little jelly beans that we have to learn about to some degree. Okay, so we'll pick that up in the next episode.